Happy Friday, happy Friday Math Hour. So thank you for joining us. So this is the room for 1332. They'll shortly be putting a link for those of you that are wanting to go to 2412. So for this Happy Friday, Happy Math Hour, we're going to start with a new chapter. And so this is going to be talking about numeration systems. And it's chapter 6 in your textbook. And then we'll look at place value systems, and then if we have time, we'll continue on to other systems. And so let's go ahead and get started here. So numerals are symbols that we use to represent numbers. And so, for example, in the past, they would use a lot of tally marks, and they would just use these sticks and cross it out to represent 5. The Chinese numeration system might have symbols that look like this. And then we had the Babylonians, the Romans, Egyptians, and many more. The one that we have here in the United States, the one we use, is called the Hindu-Arabic system. And so our numerals are these numbers like the number 8. And so we're gonna, the ones highlighted here in blue are gonna be the ones that we're gonna focus on today. So numerals are just symbols that are used to represent numbers, and a numeration system consists of those numerals and methods to arrange them to represent different numbers. Okay, so the first system that we're going to look at is the Egyptian numeration system. And the the Egyptian system is what we consider an additive system, because any given number is written using those numerals will equal that number. So for example, these are the symbols that the Egyptians use, and these are the names that are given to these symbols. And then on the left side, that is what it represents in our system. So this stroke is representing a 1, the heel bone is representing a 10, the scroll is 100, and so on. And then you have the astonished person. Some books will call this the amazed person, and that value is 1,000,000. Okay, and so we're going to be using these symbols to help us converting from one form to the other. So our first task here is going to be to convert this Egyptian numeral to a Hindu-Arabic numeral. So again, Hindu-Arabic just means our number system. Okay. So what does this symbol mean in our system? So to do that, we are going to need to remember these symbols, right? So I'm going to go ahead and bring them here. And then I'm going to write our Egyptian numeral a little bit bigger so that we can see it a little bit more clear. And so for the Egyptian system, since it's an additive system, it's a little bit easier than some of the other systems. And so here we're basically taking these symbols and applying their values to them. So for example, the fish, which is right here, represents 100,000. So right under the first fish, I'm going to write 100,000. Then I have another fish, that's 100,000. Then I have a lotus flower, which is 1,000. And I have 3 of those, so I write 1,000 3 times. And then I have 4 heel bones, so I have 10, 10, 10, and 10. And then I have these strokes of 1 and 1. So these are the values for these symbols. To convert it, we just add them together. And so this number is 3,042. So this is our number. So this symbol here represents this amount for our system. Okay. And so again, the additive system makes it easier because we're just writing down what that number is. So here's a different example. And so let's go ahead and I'm going to rewrite my little table over here on the right. And then I'm going to spread them out just so that we can see the values. So here we have 2 astonished people. So they're each representing 1,000,000. And then this one here is called the pointing finger. And I have 3 of those, so that's 10,000, 10,000, 10,000. Then we have our lotus flower. We have 3 scrolls, which are each 100. And then we have our 3 strokes. So if we add 1 million plus 1 million plus 10,000 plus 10,000 plus 10,000 plus 1,000 plus 100 plus 100 plus 100 plus 1 plus 1 plus 1, then we end up with this number. Okay, so this symbol represents this in Hindu Arabic. At any time, if you have any questions, feel free to ask us. Okay, but now what if we want to go the other way, right? So these right here, we're going from the Egyptian to the Hindu Arabic. Now we're going to go from the Hindu Arabic to Egyptian. So again, we want to make sure that we know that we're working with our symbols. So I keep writing our table on the right side. And so what we want to do is we want to rewrite our number into a sum of powers of 10. So the 2 here represents 2,000. The 3 is representing 300. The 5 represents 50. And then we have 1. But I can break this number down a little bit further. 2,000 is 1,000 plus 1,000. 300 is 100 plus 100 plus 100. 50 is 10 plus 10 plus 10 plus 10 plus 10. And then we have our 1. So now we can look at our table and see if we have any symbols for these numbers. So we have 1,000. That's represented with the lotus flower. So we're going to go ahead and write the symbol here, the lotus flower. Then we have another 1,000. So I write another flower. And then for the 100s, I write the scrolls. And then for the 10s, I'm going to write those heel bones. And then we're going to have a stroke. And so this would be your final answer, all of them together. Okay. And so for the next one, I guess I didn't do it step by step, or let me see. Yeah, it's the same one. So here the question that I have is, what happens if I happen to write one of the flowers at the end? Does it change the value of this number? And the answer is no. So since it's an additive system, if the numbers are written in different locations, their value still remains the same. Okay, so let's look at this one here. It says to write this number using Egyptian numerals. And so what we want to do here is we want to break this number down. So we have 1 million. So I'll write 1 million. Then this one represents the 100,000s. So I have 100,000. Then the 2 represents 20,000. So 20,000. And then 1 is 1,000. Then we have no hundreds. And then we have a 10 and a 1. But for this 20,000, I can write it as 10,000 plus 10,000. So 1 million is represented with the astonished person. 100,000 is represented with a fish. 10,000 is a pointing finger, and then we have a pointing finger. And then 1,000 is the flower, and then we have the heel bone and a 1, which is a stroke. And so our final answer would be this bottom part that I have. Okay. So what if we want to add? So this should be example 5, but that's okay. So use Egyptian numerals to find 23,341 plus 10,562. And so what we can do is I'm going to just rewrite them. So I'm going to represent 23,341 in Egyptian numerals. So that means that it's 2 pointing fingers, 3 flowers, 3 scrolls, and 4 heel bones, and 1 stroke. And then for the 10,562, it's 1 pointing finger. We have no flowers. Then we have 5 of the scrolls and 6 heel bones and 2 strokes. So when we're adding them, we're putting them all together. And so that is what I did here. I put just all the symbols together. But then we want to see if we have any numbers that we can regroup. Okay, so to regroup, notice here that 10 of these heel bones is the same value as 1 scroll. So I can regroup all of these heel bones, and instead of writing these 10, I can rewrite it as 1 heel bone. And so if I rewrite my number, then I have the 3 pointing fingers, the 3 lotus flowers, and then originally we had 3, 6, 7, 8 scrolls, but now we're gonna have 9 because we're regrouping these heel bones. So that's 9 of them, and then the 3 strokes. Okay, so that is how we would add using the Egyptians. What if we want to subtract? Okay, so to subtract, we have we can represent our numbers, which I did here, 61,432. I can write it as Egyptian right here. And then 45,121 is down here. And here we want to subtract 2 minus 1. So from the 2, we want to take away 1. So I kind of represented it with the red little scratch here. And so if I have 2 and I take away 1, then I'm left with 1. And then if we continue, if we have 3 heel bones and we have 2 of these, and we want to subtract 2, so we have 3 of these and we take away 2, we're only going to be left with 1. And then for this one, we have 4 scrolls, but we want to take away 1 scroll. So if I do that, then I'm left with 3. And then when I get to the lotus flower, we have 1 flower, but we want to take away 5. So there's not enough here to take away 5. So what we need to do is we need to regroup. Okay, so let me all right, so let me go to the next slide. Okay, so since I don't have enough flowers to remove 5 of them, then what I can do is I can take one of these pointing fingers and I can change it for flowers. So one pointing finger, I can replace it with 10 of these flowers. So it's gonna look something like this. So I'm gonna take this finger here and I'm gonna replace it, or I'm gonna regroup it so that I have 10 of these flowers. So now I have 11 flowers total, and I want to subtract 5. Excuse me. I want to subtract 5 of them. Okay. So now I'm gonna be left with 6. And then I have 5 pointing fingers, and I want to take away 4. So if I take away 4 from here, then I'm left with 1. Okay, and so then this would be our answer, which is 16,311. Okay, so this is a little bit of the Egyptian numeration system. Now we're going to look at the Roman numeral system. So the Roman numeral system is still used today, right? We use it when we write English papers. We use it for example, a quinceañera, people use that. We use it for anniversaries. And then one big one is the Super Bowls, right? The Super Bowls are labeled using Roman numerals. Okay, so we still have a presence of the Roman numeration system here in our country, right? So the symbols that we use for the Romans are the letter I, which represents 1, the letter V, which represents 5, X represents 10, L represents 50, and C represents 100, and then D is 500, and M is 1,000. And so on the right side here, I have 3 important rules for the Roman numeration system. And so let me go through each of these. So the first one, if all the numerals are listed so that each numeral has a larger value than the numeral to its right, then the value of that number is found by adding the values of each numeral. So what does this mean? So we look at the number the number L. Is L greater than the number to the right? So L represents 50, X represents 10, so it is. So L, we would just write 50. And then for x, is x bigger than v? And it is, so we would just write 10. And then v is going to be 5. So to find out what this number is, we just add 50 plus 10 plus 5, which is 65. Another rule is that a Roman numeral can be repeated, only some of them can be repeated up to 3 times. Okay, so the numbers that we can repeat are going to be I, X, C, and M. They may be repeated only up to 3 times. So for example, I can have X times X, I mean not times, but X and X, which would be 10 plus 10, and that would be 20. Now another one is if the value of the numeral is less than the value of the numeral to the right, the smaller value is subtracted from the next larger value. So in this example here, I have I is smaller than V. So when you see that, then that calls for subtraction. And so we would write 5 minus 1 is going to be 4. I, X, and C are the only numerals that can be subtracted from the values of the numeral to the right within 2 rows. So what that means is the number, the I here cannot be subtracted from M because it's not 2 rows within. Okay, so we need to take that into consideration. So the X cannot be subtracted from the D, and so on. So let's do some examples. So it says write DCIV as a Hindu Arabic numeral, and then example 6 is similar with just a different number. So we'll focus on 5 for now. And to help us, I went ahead and put the table on the right side so we can see what those numbers are. And so what we can do here is we can take our Roman numeral and kind of rewrite it. So the D have a bigger value than C. So that's the first question you want to ask yourself. And D is 500, C is 100, so it does. So I can write D's value, which is 500. Then I have C. Is C a bigger value than I? And the answer is yes. So I can just write the value of C, which is 100. And then I go to the next letter. Does I have a bigger value than B? So I is smaller than B, so that calls for subtraction. So I'm going to have 5 minus 1 to represent IV. So we have 500 plus 100 is 600, and 5 minus 1 is 4. So my answer is 604. Okay, let's try the next one. We have M. Is M bigger in value from C? Yes, M represents 1,000. So I'm going to write 1,000 plus, then the next letter is C, but C is not bigger than D. So that calls for subtraction. So we have C is 100 and D is 500. So I can write it as 500 minus 100. Then I go to the next letter, X. Is X bigger than L? The answer is no. So that also calls for subtraction. So we have 50 minus 10. And then the last letter is B, which is 5. So M is 1,000. 500 minus 100 is 400. 50 minus 10 is 40. Then we have our 5. So if we add everything together, we end up with 1,445. Okay, so now let's go from our number to the Roman numerals. So let's do the first one first. So I have my table here. So what you want to do is take your number 579, and we're going to rewrite it as 5 is 500, 7 is 70, and then 9 is 9. So you want to ask yourself, is there a symbol for 500? So if we look at our table, there is a symbol, which is D. So I'm going to write D. Is there a symbol for 70? There's no symbol for 70. but we can write 70 as 50, and I probably should have broken it down a little bit more here, but 70 we could write as 50, right, plus 10 plus 10. So then here the 50 is represented with L, and then the 10s are represented with X. And then 9, I don't have a symbol for 9, but I have a symbol for 10, and I can subtract 1 from it. So if I want to subtract the 1, then the I would have to be in front of the X so that we can let the reader know that they would need to subtract to get the 9. So if we put them together, then 579 as a Roman numeral would be DLX XIX. Okay, so the next one, 473, write as a Roman numeral. So same idea, 4 represents 400, 70 is 70, and then 3 is 3. 70, we said we could write as 50 plus 10 plus 10. And so the symbol for 70 is, or the value here, 50 would be L, and then 10 and 10 would be XX. 3 is 3 of these I's. And then for 400, I can take 500 and subtract the 100 from it. So I can write it as CD to represent 500 minus 100 to give us 400. So this would be our answer. Okay. Let's try this one. Write 5,179 as a Roman numeral. So if we kind of follow what we've been doing, we have 5,000 plus 100 plus 70 plus 9. So 5,000, our largest value here is M, which is 1,000. So maybe I can write 5 M's here, and then 100 is C. 70 we know was 50 plus 10 plus 10, and 9 is IX. So is this our answer? And I'm asking the question, what is the problem with this answer? Okay, so if you remember the 3 rules that we had at the beginning, the letter M, or basically any of these letters, cannot be repeated more than 3 times. Okay, so there's a problem here if we write 5 M's. So let's continue and see how we can fix this problem. So if you see a Roman numeral with a bar on top, like the V here has a line on top, that represents that we take that value and multiply it by 1,000. So here the V represents 5. Since I have a bar on top, I'm going to multiply that value times 1,000. So we get 5 times 1,000 is 5,000. Okay. So the next one here we have CD. So we need to see the value of CD. C is smaller than D, so that's 500 minus 100 is 400. Since I have a bar on top of both the letter CD, then we multiply the 400 times 1,000, and we end up with 400,000. Okay, so that is how we can fix the problem whenever we have a bigger number like this. And so if we fix our problem here, instead of writing 5 M's, we can write V with the bar on top, and then we have our C, LXX, IX. And let's try an example over here. So let's do these two. So it says write IXL as a Hindu-Arabic numeral. And so we can see that we have a bar here, and the bar is on top of the I and the X. So I represents 1, X is 10, so we need to subtract. So IX is the value of IX is 9. It has a bar, so I multiply by 1,000, and then L is 50. So 9 times 1,000 is 9,000, plus 50 is 9,050. if we want to write 8070 as a Roman numeral, then the 8 is going to be 8,000, and then we have 70. So 70 I can write as 50 plus 10 plus 10. I have no value for 8,000, but I know that I can multiply 8 times 1,000 to give me 8,000. And so I would write 8 can be written as V I. I'm going to put a bar on top of that so that we know that we're multiplying by 1,000. And then 50 is L and 10 is X. So our answer here is going to be V I with the bar on top, LXX. Okay, so that's how we convert from the Romans to our system, and our system to the Romans. So now we're gonna kind of change into two other systems, but before we do that, we want to talk about what place value means. Okay, so our system, as I mentioned earlier, is called the Hindu-Arabic system, and we say that we're a base 10 numeration system. And so one of the rationales for why we have a base 10 system is because we have 10 fingers, right? So a lot of these places like the Egyptians, the numeration, the Mayans, the Babylonians, they created their bases based on something about themselves. And so like here for base 10, whenever somebody says that you're a base 10, that means that your symbols, you should have 10 of them. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are numerals, and there's 10 of them. Okay. So in the number 31 and 13, does the number 3 represent the same value? Okay, so we know that that is a no, right? Because 31, the 3 here represents 3 tenths, and the 3 in 13 represents 3 ones. So the position of a digit determines the value of that digit. So depending where that number is located, it's going to have a different value. And that's why we have what we call place value numeration system. Another important thing to note here is that since we're in base 10, this is going to help us with the place values. So our very first place value is 10 to the 0 power. Then we have 10 to the first power, 10 squared, 10 cubed, 10 4 to the fourth, 10 to the fifth. And then the 3 dots here represent that this will go on forever. Okay. And we'll be using that in the next examples. Now 10 to the 0 is the same as 1. Okay, so this just means the ones place. All right, so we want to write 17,325 in expanded form. And so expanded form, what that means is we're going to look at our place values here. And so we take this number, 17,325, and we're going to break it up into what we call expanded form. So the 1 here represents 10,000, 7 is 7,000, 3 is 300, 2 is 20, and then you have a 5. So to write it in expanded form, then we would take the 5 that's in your first position. So we say 5 times 1. The 20 is in the second position, which is 10 to the first power, which is 10. So we write it as 2 times 10. And then the 300, that's in the third position, which is 10 squared. So we would write 3 times 100. And then for 7,000, we can write it as 7 times 1,000. And then the 1, we can write it as 1 times 10,000. And then from this row here, we can write them as 5 times 10 to the 0 power if we want them in powers. and then 2 times 10 to the first, 3 times 10 squared, 7 times 10 cubed, 1 times 10 to the fourth. And this would be important when we're trying to convert from one system to another. And so let's try, oh, I thought I had another one. Okay, well, we'll be able to practice with this system here, okay? So the next system we're gonna look at is the Babylonian numeration system. They are in a base 60 numeration system. They actually only have 2 symbols. They have this one that represents a 1 and an arrow that represents a 10. And there's actually a third symbol, but your textbook does not have it. But I'll talk about that in a little bit. The other important thing here is the place values. So instead of 10 to the 0, since they're in base 60, it's going to be 60 to the 0 power. Then we have 60 to the first power, 60 squared, and then 60 cubed, and then it's going to go on forever. And so 60 cubed is the same as 216,000. 60 squared is 3,600. 60 to the first power is 60. 60 to the 0 power is 1. So any numbers that are less than 60, the Babylonians were similar to the Egyptians in that 42 would be written as 4 arrows and 2 of these triangles. So each arrow represents 10, so that's 10, 20, 30, 40. And then these represent 1, so 1 and 2, so that gives you 42. But if the number was greater than 60, then they are going to be using place value. And so they would use a space between each group to indicate that they have moved on to another place value. So if you look at this number here, there's 3 groups. Let me get the pencil. So you have this group here, and then you have this group and this group. And if you notice, there's spaces in between each of those groups. So the first group, that represents that it's in the ones place. And then the second group represents that it's in the 60s place. And then the third one would be in the 60 squareds place. Okay. So let's go ahead and convert. I think it's the same number here. Let's convert this to see what it is in our number system. Okay, so the first thing you want to do is, and I thought I had it separated, but I guess I don't. So the first thing you want to do is get your groups. So we have 3 groups. So this is one group, another group, and then my third group. Then what you want to do, or what I like to do, is under that first group, I like to put the place value. So this is in the 60 to the 0 power. This is in the 60 to the first power. And this is in the 60 to the second power group. Okay. Then we want to figure out, well, what does each group represent? Like, what's the value of each group? So here I have 2 arrows. So that's 10, 20. And then I have 5 of these. So that's 25. And then this one is 10, 20, 30, 1. So 31. And then this is just a 1. So now what we're going to do is really, what we're doing is kind of writing it in expanded form, right? So we have 25 times 60 to the 0 power, 31 times 60 to the first power, 1 times 60 squared. And then what is 60 squared? That's 3,600. And then 31 times 60, and 25 times 60 to the 0 power, which is 1. So 1 times 3,600, 3,600. 31 times 60 is 1,860. 25 times 1 is 25. If we add these values, we get 5,485. Okay, so that is the process to change from Babylonian to Hindu-Arabic. I think I should have another example. And so here we want to convert this number to Hindu-Arabic. And so again, we're going to take our number, I'm going to identify my groups here. So I have 4 different groups. There are spaces in between each of these. And here is our information about the Babylonians. And so now I'm going to go ahead and write the place values. So this first group is under the 60 to the 0 power. The second one is under 60 to the first power. Then we have 60 squared and 60 cubed. Okay, so now I want to identify what does this mean, what does this mean, what is this, and what is this. So right above it, I'm going to write this represents 1. This one is 10, 20, 30, 31, 32, 33, 34. This is 5. And then this is 10, 21. And now I'm going to multiply them. So we're going to have, let me see. I probably didn't change it. Let me go one more. Okay, there we go. So this one here. But on the next slide, I have it correct. All right, so we have 1 times 60 to the 0 power. We have 34 times 60 to the first power, 5 times 60 squared, and 21 times 60 cubed. So 60 cubed is 216,000. 60 squared is 3,600. And if we multiply it out, 21 times 216,000 is going to be 4,536,000. And 5 times 3,600 is 18,000. 34 times 60 is 2040. And 1 times 1 is 1. So if we add all of this together, then this is our answer. Okay. So that is how we convert from Babylonian to our number system. How do we go the reverse way, right? How do we take our number and convert to the Babylonians? And so here, again, we're going to be using our place values. So one of the things that I like to do first is I just like to rewrite my place values. And so here, let me go ahead and 60 to the 0 power is 1. So it should be a 1. Then we have 60, and then 3,600 and 216,000. So what you want to do is we're going to be dividing. So we write our number 8,503, and you want to ask yourself from these place values, 216,000, 3,600, 60, and 1, and remember there's more to the left over here. Which of these place values can we use? What is the highest place value that will go into our number 8,503? And so 3,600 will go in here twice. So 3,600 times 2 is 7,200. So if I subtract, I get 1,303. Okay. So then what we want to do next is we're going to take our remainder. So this is our remainder. And then we're going to divide by the next place value. So if we started with 3,600, the next place value is 60. So we start with 60. So 1,303 divided by 60 goes in 21 times. Times 60 will be 1,260. If we subtract, we get 43. And so we keep doing this process until we get to the last place value. So after 60, we have 1 is our place value. So again, this should be a 1. Okay, so we take our remainder, divide by the next place value. So that goes in 43 times, and then we end up with a remainder of 0. So now what these numbers mean is that these highlighted numbers here, 2, 21, and 43, that is what you're going to rewrite using the symbols for the Babylonians. So the number 2 can be written with these 2 triangles. And then I'm going to a new place value. So I'm going to leave a space. And then I have 21. And that's going to be 10, 21. And then I'm going to a new place value. So I need a space. And then 43 is 10, 20, 30, 43. Okay, so let's do another one. 12,578. And so if we put our place values, then the first number that will divide 12,578, or the largest one, will be 3,600. And that goes in 3 times. So 3,600 times 3 is 10,800. If we subtract, we end up with 1,778. So we're going to take our remainder and divide by the next place value, which is 60. That goes in 29 times. Times 60 is 1740. It's giving us remainder of 38. And so now we go to the next place value, which is 1. So 38 divided by 1 goes in 38 times, and then we end up with remainder of 0. So our answer can be written as 3. So we have our 3 triangles. I need my space, and then 29. I need another space, and then we have 38. So that would be our 38. So this would be our answer. And I have one more, 57,600. And so let's see what happens here. So we have, again, our place values. So don't forget, this is a 1. And so the first place value that will divide 57,600 is 3,600. And that goes in 16 times with a remainder of 0. Okay. So the question here is, do we go on, right? Or do we just stop at this place? And do we write our answer as 16, right? Or do we keep going? So you always want to make sure, if you start with 3,600, you always have to go till the very end, to the last place value. So we're going to keep going. So my remainder of 0, I'm going to write it in here. I go to the next place value, which is 60, and I get remainder of 0, or it goes in 0 times. 0 times 60 is 0, so we end up with 0. I have to do this again. Now my next place value is 1, so we end up with 0. Okay. So now that we have finished our last place value, then we can write our answer. So we have 16, so I wrote 16. Okay. So the big question is, how do we know that this is 16, or is this 57,600? So right now I know it's 57,600 because we just worked out the problem. But if I gave somebody this right here, how do they know that it's 57,600, or is it 16 only? So this 0 means that we need to go to these place values. So we just put space, right? So here's a space, and here's a space, but we can't see the space. Like, let me go back really quick. Here I can see I have a space, and I have a space. But the problem with the one that we're doing is there's nothing over there. Okay, so earlier I said that there was one more symbol that we can use. That's not in your textbook though, but it does exist, and that symbol is 2 triangles, one on top of the other, and they're used to represent, it's a placeholder for 0. Okay, so here we have 16. This is my 16, but in my next place value I have 0, so I use this placeholder. And then my next place value I have a 0, so then here is my placeholder. So now I know for sure that this is in the 1's place, this is in the 60th place, and this is in the 60 squared place. So I can calculate this as 57,600 and not 16. Okay. All right, so let's go to another group, the Mayans. So the Mayans were actually one of the first to have a symbol for 0, to actually say this is the number 0. And the symbol looks something like this. And then they only use dots and they only use lines to represent their numbers. So like number 1 is at 1 dot, 4 is 4 dots. When you get to 5, you have a bar. So then 6 is going to be the bar and the dot. And then when you get to 9, it's a bar and 4 dots. 10 is going to be 2 bars, and so on. And then their last numeral is 19. So if their last numeral is 19, can you guess what base they're in? Like we're in base 10, Babylonians were base 60. Their last number is 19 here. So their base is actually base 20, okay? But they're a little bit different. They wanted to do things based on their calendar. And so their place values start with 20 to the 0 power, which is 1. Then they go to 20 to the first power, which is 20. But then they throw this 18 in here. So 18 times 20 to the first power, and then 18 times 20 to the second power, 18 times 20 to the cube power, and it goes on forever. Okay, so they threw in this 18 times 20, 360. So they were using a calendar, and that's what they decided to do. They also are different in that they write their numbers vertically, okay? So if we wanted to write this number as a Hindu Arabic, then the first thing you want to do is identify the groups, okay? So this level here is your first group, then the second level is your second group, and then the third one is your third group. And so this first group is in the ones place, the second group is in the 20th place, and then the third group is in the 18 times the 20th place. So if we calculate it, we get 11 times 1 is 11, 8 times 20 is 160, 10 times 18 times 20, 3,600. And so my answer is 3,771. That is what this Mayan numeral is in our system, okay? So let's try this one. And I think I have to write it because I ran out of time here. So let me get the pencil. And we're going to identify this group as our first group. So here we have 3 dots, so that represents 3, okay? And then it's in the first group, so I can say times 1. Then we have the next group. So that's 5, 10, 11, 12. Okay, and so remember the next group is going to be 20. So we're going to say times 20 times 20. And then this represents 0, and that's in the next group, so that's times 18 times 20. And then the last one is 5, so that's going to be 5 times 18 times 20 squared, okay? And so if you have the table, you can see they give you that number here, 7,200. And so then we're going to use our calculator to get these, right? So let's see. So let's start with the first one. We have 20 times 20 times 18 times 5, and that's 36,000. So 36,000. And then this is going to be 0, because 0 times 360 is 0. And then if we go on to the next one, we get 240. And then 3 times 1 is 3. So to get your answer, you're going to add all these four numbers. So we get, let's go ahead and add them. So 36,243. Okay, so let's do the next one. We have 4 dots. So I'm going to write it here. So 4 times 1, and that's 4. Then we have 5 and 5, so that's 10. And that's in the 20th group. So 200. And then we have 1 dot. So 200. And then we have 1 dot. So 1 times 18 times 20. 18 times 20 is 360. And then the last one is 9. 9 times 18 times 20 squared. Okay, so let me do that one on the calculator. 20 times 20 times 18 times, times 9. So 64,800. And then we want to add everything else. And we get 65,364. Okay. All right, so let's go to the next one. So now we want to write 7,495 as a Mayan. And so we want to make sure that we look at this right here. And so what you want to do first is write those place values. So we're going to have the ones place, the 20th place, 18 times 20, which is 360. And then the next one, I think, is 7,200. And I think the next one is 144. Okay. So let's go back. And then 100. And then this will go on forever. Okay. All right, so we take our number 7495, and we want to divide by whichever group will go in here first, whichever place value will go in here. So that would be 77,200. And so that goes in 1 time. And we just subtract now. So we have 5, 9, and 2. Then we're going to keep going. So we have 295. And we want to divide that by the next place value, which would be 360. But 360 will not go into 295. That goes in 0 times. And so we keep going. So 295. And now we're going to divide by the next place value, which is 20. Okay, so here, so 295 divided by 20 is going to go in 14 times. Okay, so 14 times 20 is 280. And we get 1 and 5. And then we keep going. So now we have 15 and 1 is our next place value. And so we get 0. Okay, so now we're ready to write all this in symbols. So we start with the ones. We want to write 50, and so we get 0. Okay, so now we're ready to write all this in symbols. So we start with the ones. We want to write 15. I can write 3 bars. So that's 15. And then 14 is our next one. So I skip a space. So we have 5, 10, 11, 12, 13, 14. And it should be vertical. So I'm not sure why I'm going sideways here, but the next one is, let me try to straighten it up, 0. So we represent 0. And then the last one is 1 dot. Okay. And so that would be our answer. Okay, let me go on to the next slide really quick. Next week, we'll kind of touch up on this a little bit more. Actually, I'll just go to this one. And then next week, we can start the new basis. I only have 3 minutes, so at least get started with this one. So again, you have your ones place, your 20ths place, your 18 times 20, which is 360. And then it was 7,200. And then it was 144,000. So you want to take your number and see which place value we can divide by. So the first one that will divide it is 7,200. And that will go in 1 time. So 1 time here. Okay, so we have 11,480 minus 7,200 is 4,280. And we continue our process. So the next place value that will divide this is 360. So 360. So that goes in 11 times. So that gives me 3960. And the remainder is 320. So then we go to the last place value. And we get 16. And so then the last place value, don't forget, even though you get a remainder of 0, you have to keep going to so you can use the last place value. Oops. Okay, so now to write our symbol, it's going to be 0. So that's a symbol for 0. Then you have 16, 10, 5, 10, 15, 16, 11, 5, 10, 11, and then 1. Okay, so this is our answer. All right, so for the next week, we'll do some more bases here. We'll talk about different bases, and then we'll be doing some adding and subtracting with different bases. And the idea is for these right here, they work the same as what we've been doing with the Mayans and the Babylonians. Okay, and so like just really quick, I have like 5 seconds, but if you're in base 5, then you only have these numbers 0, 1. Quick, I have like 5 seconds, but if you're in base 5, then you only have these numbers 0, 1, 2, 3, and 4. And your place values are the ones, the 5 place, 5 squared, 5 cubed, and then so on. If you're in base 4, you would just have 0, 1, 2, and 3. And your place values would be 1, 4, 4 squared, 4 cubed, and so on. But we'll talk about that next week. So that is it for today. Thank you for coming. I hope to see you next week.
Thank you so much. Have a nice day.
Thank you, Ms. Truca, for your wonderful presentation. Before everybody leaves, we want to remind you all about the previously recorded sessions, which are available on the YouTube playlist. The session will also be available on that playlist a little later today. And before you leave, I'll share the TBE sessions that we'll have next. At 1 p.m. today, we will have a presentation on the Engineering Academy with Dr. Rebecca Escamilla, and we will be back next week at 11 a.m., where Math 1332 will cover arithmetic in different bases and prime numbers, and Math 2412 will cover the exam 2 review. Our 1 p.m. session next week will be a presentation on CSD with John Estrada and the Writing Center with Vanessa Zuniga. Thank you all for coming in today. We hope you all have a lovely weekend. And if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.